Very good. Well, thank you. This is Marc Goldman. I'm the Industry Solutions Director for AEC at Esri, and it is absolutely my pleasure to be moderating, facilitating, and participating in this GIS for Subsurface Utility Engineering webinar, a topic that certainly is near and dear to my heart. I tend to focus on the architecture, engineering, construction firms who are building out the infrastructure of the world, and I about a year and a half ago, actually dove pretty deep into the topic of subsurface. I guess no pun intended there, digging deep. But this was a topic that I got to know several of Esri's partners, customers, users, and this topic of subsurface engineering. So when I was asked to participate in this webinar, I jumped in feet first. So thank you for participating as an attendee and a listener. Hopefully you understand how to use Zoom and you'll send your questions to us. We're eager to hear from you through the questions panel, and we'll be asking a couple questions of you first with some demographic polls. It's always great to know who is dialed in. We want to know what type of organization you are part of. Are you a local or state government, a federal government? Maybe you are representing academia or industry. Maybe you're an AEC firm, maybe you're a utility company, a consultant. We also want to know where you are coming in from. Is it here in the US? Are you up north in Canada? Maybe South America, over in Europe, Africa, or Asia? It's always great, like I said, to know who we're talking to and who's listening before we jump into our content. So please take a minute and let us know about yourself. We'll just take a minute or so for that to run until all of the responses come in. Give that maybe another few seconds here. I'll answer myself if it lets me. No, I'm a presenter, so I can't vote.
Folks, go ahead and please answer the demographic poll as soon as possible, and then we'll close it up and share the results.
Knowing who's here and what groups you represent and where you're connecting from will allow our presenters to talk maybe more directly to you. Interesting, almost no one from academia, no one, zero. Industry represented almost 20%, local government, the majority, state, and a few folks from federal. That's really great to see. And then dialing in, no surprise, almost everyone from the US, someone from Canada, and someone from Africa. Wonderful. Oh, there was another question I didn't actually realize. Business sector, almost just didn't scroll through. Public works is our biggest group here, as well as transportation, and then municipality. Most folks from fairly large municipalities, 100,000 or more. So that's great. That's really important for us to understand, like I said, before we get into this topic. And as you can see, the webinar itself, GIS for Subsurface Utility Engineering, that's what we're connected into. I'm going to start out a little bit with an overview of Esri and GIS in particular, and just the importance of location as it pertains to the world of infrastructure. I'm going to guess that this is somewhat a self-selected audience of folks who know of Esri. You may not know, the latest and greatest about us. We have been a leader in the world of GIS since really the concept of GIS came into being. Our founder, Jack Dangerman, 55 years ago, formed the company, and we continue to find ourselves becoming critical technology, critical capabilities, certainly in the world of infrastructure, helping organizations really of every type apply geographic thinking, location intelligence, using context to help build better, if you will. Esri has grown over the years. We now have roughly 10 million users around the world. You'd really have a hard time finding any spot on the globe where our technology isn't being put to use, certainly for the world of architecture, engineering, construction, operations of utilities, water, gas, buildings, transportation, you name it. Also outside of perhaps the area that we all have an interest in, we're also really the standard technology in logistics, government affairs, near Earth orbit, visualization. 33,000 businesses are using our tech And like I said, around the globe, utilities are a large group of customers, and then the AEC firms who are serving infrastructure and utilities are also a big growing part of the world of Esri. And the reason that I believe that we are becoming so commonplace in so many industries is there's a lot of questions related to where, certainly as it pertains to infrastructure and utilities, telecom, water, buildings, transportation, hospitals, et cetera. Where's the optimal site? Where are the resources that might be needed in the workforce to get things built? Where are the regulatory limits that might be constraints and boundaries and issues to consider very early on in planning and all the way through into operations? Where can costs be minimized? Certainly, projects of all types are concerned about costs, and the question of where can help answer how to save money. Where are the assets located that you're working on? Where are they underground? Where are they relative to other construction projects? Where are they relative to the consumers who need to have access to those utilities? Where will traffic be most affected or improved or perhaps negatively impacted as it pertains to tearing up a street, putting down new lines, making resources more easily available to communities? Where are noise levels critical? People want to know, when noises are occurring in their neighborhood because something is being dug or buried. These are bits of information that can be communicated to consumers. Where are the material storage areas is certainly a critical issue of most types of construction projects. Rarely is there a site of unlimited size where materials can be dropped for maybe an unlimited amount of time. So where are you going to put your raw materials before you start to cut up the ground and bury them underneath? And all of these where questions are just critical to the world of utilities. Where are utilities located is a big question in a compressed timeframe and compressed geography of where our utilities need to go. And GIS, modern GIS, certainly answers those where questions. And I find as I go to various conferences and meet with customers of different types and meet with different audiences, the understanding of GIS tends to vary. That first box in the upper left corner there, the mapping component of GIS is what most people know about, might remember from their university work or just past experience with GIS. But GIS is much more than just a map that might exist on a screen that might even get printed out. GIS is certainly field operations, collecting data on existing conditions, collecting information as construction is occurring, and certainly knowing what's going on underground is a field operations work. Being able to take the map data, the field collected information, the various layers that range from satellite imagery, fixed wing, drones, and underground, and being able to analyze the spatial conditions and perform data science against the massive amounts of data that gets collected in infrastructure projects. As I mentioned, the imagery and remote sensing, knowing what is going on in real time and perhaps even knowing what went on in the past and using that to help guide the engineering of our utilities, certainly at a subsurface level. Using sensors of various types, whether it's RFID tags that might exist on utility lines, or using various types of ground penetrating radar and other types of imaging to understand those real-time conditions below our surface, and then visualizing them in 3D and analyzing the location of various assets relative to each other. Understanding all of these elements in context leads to better subsurface engineering. And GIS is very much a data management platform. GIS, certainly in the world of Esri, has almost always been data-oriented as opposed to file-oriented. And as the world of infrastructure is moving more towards data-based approaches, we're seeing GIS as this foundational layer that just enables many more capabilities. And certainly in the world of Esri, all of the capabilities you might know about and use to develop better maps and bring your field data in and do spatial analytics, almost all of that exists on the desktop is also available through developer APIs. So partners and customers like are on the webinar today are very likely using those capabilities to extend the software beyond just the features and functions that Esri builds into the product itself. So the importance of accurate subsurface data, it really cannot be overemphasized. Knowing where in a map-like context our underground utilities are as new roads are being added, as our utility grids are being expanded to support solar and wind, as many cities around the country are doing both above ground and below ground transit systems, as new buildings are coming in, replacing old ones. The understanding of the location and the types of utilities that exist and have been placed over a century or more in the US certainly is of critical nature. And GIS helps to reduce the risks of hitting existing lines, breaking existing infrastructure, putting people in harm's way by that element of location. Knowing where things are, how close they might be to new construction helps with the planning, the actual construction, and the long-term operations. So it really cannot be overemphasized how important getting a clear understanding of subsurface utilities are, doing the engineering work around that, and the fact that GIS is so well positioned to bring in these various layers of data addresses those risks that exist as it pertains to our subsurface utilities. It acts as a data integration platform of the many types of data that I've mentioned. It helps with visualization and analysis, and it's not just visualization at an engineering level. Very often, the visualization capabilities of a GIS environment help a broader group of stakeholders understand conditions than they would ever be able to get from CAD drawings, BIM files, 3D animations. But the real-time, almost immersive capabilities of GIS enables visualization and analysis to inform a larger group. Certainly, conflict detection and resolution, one of the just inherent capabilities of GIS, knowing where things are, helps you know where things shouldn't be, helps you know where things might be overlapping, helps you know where to dig. And again, that results in safety improvements. And at the end of the day, after you've planned, designed, engineered, and constructed your utilities, the perhaps longest term, and some might argue the most important part of those utilities, is managing them for the long term. Making sure they don't get hit again, making sure they get maintained when the time frame is correct, understanding risk at a broad scale, perhaps of an entire portfolio, maybe an entire city, so that you're managing your asset in the most cost-effective, safest, and predictable manner. And so with that sort of as a starting point and some thoughts to consider, I'll just leave you with a couple of calls to action here as we make our way into our next presenter. One, there's so many tools in the world of GIS, technologies, capabilities, consultants who have expertise that help with subsurface engineering projects. So hopefully this is, maybe not your first intro into the topic, but we really hope that, after this webinar, you reach out to myself or any of the other presenters to continue to become more informed, and stay tuned for info from the rest of our great presenters. And with that, I will hand it over to Wes Kaisershot from CDH Utility Systems.
Perfect. Hello, everyone. Thanks for attending here today. Thank you, Mark, for that introduction and that pass off. As we continue to talk about GIS solutions and GIS capabilities in subsurface utility engineering, I wanted to introduce myself, Wes Kaisershot with CDH Utility Solutions. I am Vice President of Growth and Engineering for the company. We're a growing subsurface utility engineering firm, utility asset management, pole inventory, manhole inventory, ground penetrating radar, anything you need to map out utility network and put it into CAD, put it into Autodesk or Open Roads, even 3D modeling, we're here for you. So company based out of Atlanta, Georgia. I myself am in just north of Austin, Texas in Leander, and happy to be on this presentation today. So as we continue to talk about GIS and SU, we're going to be talking now about how there's unique capabilities and how you actually deliver a SU product and what that means with GIS. If I could, I think we're going to do a quick poll to kind of keep things interesting. So on the poll question here, like you to participate out there. It sounds like there are about 150 folks out there, which is pretty cool. And the first question is, with your knowledge of subsurface utility engineering and SU, what's the most certain level as to the location of that utility? Is it quality level D, B, is it C, is it A? If you could answer that, multiple choice. see your quick overall understanding of Sioux. I'm sure there's some experts out there, maybe some of you that are a little bit new. And the second question, if you could answer, I like history. What year was the first Sioux standard published? Prior to its update last summer, it was July of 2022. What year was the previous Sioux standard published? And I'll give you a hint, it was put out by American Society of Civil Engineers, ASCE. So we'll let those poll questions run for just a little bit. Go ahead and kind of think about those. And I'm going to talk about the next slide, and we'll come back here shortly with the poll results. So GIS and Sioux, how are they related? What's the reason we're talking about GIS and Sioux? Well, I always like to look at definitions. This one came from a lot of our sources of knowledge nowadays, Wikipedia. GIS defined as consisting of integrated computer hardware and software. I know we have a couple folks here presenting today that are on the software side of things. Computer hardware and software that store, manage, analyze, edit, output, and visualize geographic data. Well, why is that important to Sioux? Because the definition of Sioux here on the next graphic here is that subsurface utility engineering has emerged in the last few decades. Believe it or not, Sioux has been around since 1980s. So it's not as new as some people think. It's been around for a long time, but the education of it continues today, which is kind of fun, and which is why I'm doing what I'm doing. So Sioux has emerged in the last 3 decades as a professional effort and best practice for performing and documenting the results of utility investigations, what's out there, what's underground. Maybe it's at the design stage of your project. Maybe it's at the construction stage of your project, and you still need to know where the utilities are because maybe you hadn't received a good existing utility drawing or plan before the construction began. And so it's that performing and documenting of it. We're going to talk about the performing in a little bit. You'll see examples of how to perform Sioux here in a little bit. Of subsurface utility engineers, and they acquire, process, characterize, and assess quality levels and present that utility information for project development. That comes out of the new standard ASCE 3822, which our company and many others out there, if they're performing Sioux, they need to be performing it to the ASCE 3822 levels at this point, and the quality of care. But you'll notice some key words in the definition of Sioux that match with the definition of GIS. Analyzing data, output, visualizing geographic data. That's what Sioux is in the end. Sioux is GIS information at the end, presented to you in a format that allows you to know where utility conflicts are in your design and construction. So that's a little bit of GIS and Sioux, just some fun definitions that make sure that we're presenting on something relevant here today. If we could go to the poll results, I'm excited to see what folks know about those 2 questions of Sioux. So there's the first one. So with all the folks participating, what level of subsurface utility engineering is the most certain as to the location of utility? I probably should have described certain, but certain means that you really know where that utility is. You have a high confidence level of where that utility is, maybe in the X, Y, and Z. So we had about interesting spread here. Majority said level A, and I will give a shout out that 62% were correct. Quality level A is the most certain level to your knowledge of a utility's location. Quality level D, B, and C, though, for those of you that answered that, they are not unimportant at all. When you cannot find the utility to level A, then a professional in charge, a civil engineer like myself, or others that are certified to stamp a Sioux deliverable for the client, they do have to distinguish that to a C, B, and D level if you can't find exactly the utility to quality level A. So pretty good poll information, and the reason that we still educate today. So thank you all for answering that. Now the history buff question. I think I need to hit close on this. Let's see if we have the results yet for the second question.
Yes, I can read the results for you.
Thank you.
40% who said 1990, 41% said 2002, 6% said 1776, and 13% said 2011. And the question was, what year was the first Sioux standard published prior to the update in the summer of 2022? And the correct answer is?
So I really appreciate the 6% that put 1776, because that is, of course, the year our country was founded. So that's awesome. The correct answer, though, is 2002. So congratulations to, was it 40-some% that answered 2002? So really, Sioux became known and credited as an engineering profession, and helped folks like myself take a path in utility engineering in 2002, when it was recognized by ASCE. And then, of course, 20 years later, we're not going to wait that long for updates, but in the first iteration, it took 20 years to get updated. So the 22 standard now is what we have. So appreciate those participating on the poll questions. Thank you very much. So we're going to have, in a couple more presentations after this, I believe one of them is going to expound a little bit in more detail of the quality levels of Sioux, but I'm going to do my best to show you pictorially and also define those quality levels. So we talked about how quality level A is the most certain level. They are levels of certainty. There's a picture of the standard that we operate under now. Quality level A is a value assigned to an X, Y, and Z position. So if you think about a three-dimensional position of utility, you've got the X and the Y on the ground level, but with level A, you've actually exposed that utility through a test hole, or you've daylighted it. You even maybe open trenched it with a hydrovac, or the soil's been soft enough or sandy enough that you could do that with air pressure. But in some geophysical method, you've opened up and exposed that utility to see the diameter of the pipe, to see the diameter of the conduit, or the width and depth of a joint duct bank or a box that houses other utilities. You've actually exposed it. So then if you survey the middle of that, now you have you can check the circumference of that utility. If you've exposed enough, you can know exactly the diameter of it, and now you know the depth of it. So level A is at this level, at this time, the most certain level. Now quality level B is super important too. So we're going from the highest quality level to the lowest. Level B, you are still using geophysical methods. It is a value assigned. And when I say value assigned, that's where a professional in charge, like myself, or it could be a surveyor in some states, or myself in many states as an engineer, it could be a geophysicist license. That's a professional in charge. They're actually designating the quality level after everything's been worked out to see how well you can find that utility in the field. And at level B, it is a value assigned to a utility segment or feature. And by that, it could be a fire hydrant, it could be a manhole, it could be a water valve lid, but a value assigned to a segment or feature based on geophysical investigation. So at some level, you have to have found that. You've had to tone it with a pipe and cable locator. You have to have radared it in with a ground penetrating radar and seen some kind of curvature readout on your screen for the field investigator. You're using maybe a sonde, which is a large reel of cable with a detecting device on the end that can go down through a storm drain pipe that doesn't have any metallic quality. And because that detection material, that detection tool is snaking through a pipe, then at the ground level, you can detect the location of that utility. It could be a high-powered magnet, but you've located that utility or that feature, and now you can survey it in and mark it. It's then level B. Level C, as we go again, a little bit less certain than that, but still important. You have a utility segment that's not visible, but what is visible is the utility features, surveyed utility features, like the definition there shows. You've surveyed those in. The standard even calls those anchor points. If you're kind of a surveyor and you like those kind of frames of terms, you know that anchor point. You know that there's a manhole here. You know that 500 feet down the road, there's another manhole. Quality level C says because you've surveyed in those utility features, now to level C, you can confidently draw a segment between if that's the best information you have. So that's level C. Level D is the least certain, and that kind of leads into the next slide. But on level D, the least certain is when all you really know is the utility location via records, or maybe a field site visit, or maybe a Google Earth look to where the utilities are. However, that leads up to the next slide. Back in the day, for those of you that are familiar with SUE, it was calling utility companies. It was finding who would be friendly at AT&T or Suddenlink or large power companies across the country. And if they could, as timely as possible, provide a set of records. So real quick, I'm just going to pause quick. I don't see myself. Am I visible to everyone as I talk?
Yep, we can see it just fine.
Okay, great. All right. Just making sure everything's working good. Thank you. So level D used to be kind of what we call the old school record of utility record gathering, and that could take days, weeks. You might never get all the records. But for a small plug for a company that I've partnered with over the years, and that's out there now and making big waves across the country, is Forum Analytics. So what? AI, everyone's talking about AI. There is AI in the SUE process, and it is in the utility records collection phase. And above is a little screenshot example of a platform that I have where I could draw the limits right around that roadway project. This happens to be a job on the east side of Austin, Texas. And the roadway on the left is State Highway 130, a fairly new toll road that connects Austin and San Antonio thereabouts. But to the right was a development from a client where they needed to know the utilities along this side road that kind of fed into that major toll road. There was going to be some prime development out there, so they needed to know the utilities. I literally drew that segment, and right away utilities are popping in what 4M calls foundation data. It's real-time utility information, foundation data right there popping in to a project, and it helps a SUE professional like myself and our company know where the utilities are to a records level right away, because artificial intelligence has looked at aerial imagery, satellite imagery. They've collected public domain information into their machine learning, and they've collated it all together into this huge database that you can tap into with subscription type plans that they offer. So yes, AI is used in SUE, and it helps with the GIS output of our SUE product. So next slide. There are, in order to do SUE, there are geophysical methods. So what is geophysical? It's using tools of the trade to locate utilities, to expose utilities. So I'm going to show you here on the next couple slides pictures of kind of what we're talking about. So on the left, this is how cool SUE can be. We can actually dig a test hole or a small trench. We can actually do very large trenches now with hydrovac capabilities, with water pressure. But you're seeing there daylighted utilities, what the SUE standard calls a test hole. And in this test hole, this was a golden winner, because in one test hole, we have found 3 utilities. That looks like a fiber optic line in black. That yellow line is probably a natural gas line. And then this other one is a conduit. There could be a fiber optic network inside that conduit, some number of pair of fiber. So what that does is that, again, now we know at that spot the X, Y, and Z of utility location. Another geophysical method is the GPR, ground penetrating radar. That's a nice buzzword that a lot of people are getting excited about. It looks like that man's pushing a lawnmower, but there isn't much grass for him to cut. Not a whole lot of satisfaction level to cut grass there, especially with that construction fence. But what he's doing is not pushing a lawnmower. He's pushing ground penetrating radar, and that signal that channel or multi-channel unit underneath those 4 wheels is reading up into a display that he's looking at hand level. And he's looking for any sign of a curvature of a pipe, of a repetitive piece of information, so that he knows that there's something bouncing down and coming back up in a signal that would show the existence of a utility. This is very handy when you can't pick it up with a pipe and cable locator. which would be a traditional sense too that we may or may not have a picture on this presentation. The geophysical method on the right is a hydrovac truck. You could also look at it as an air excavation truck, because what's happening here is water pressure, air pressure, in this case, water pressure has dug a hole. And if you look further back on that photo, you'll see a utility pole. Well, this owner needed to put another utility pole. So they needed to know in a large radius diameter area of a hole, they wanted to make sure that there wasn't any other utility. So we non-destructively were able to excavate down and then suck the soil. And this is hydrovac, so it has a more powerful vacuum machine, and it's actually sucking the water saturated mud and the sludge made from excavating down into that truck, and it's holding it into a tank so that we can go down and slowly non-destructively expose that utility. So that's another geophysical method. Next slide. Geophysical method there shown as well. We don't just excavate through soil or soft dirt or a soft dig. We can go through concrete, asphalt, pavement, as seen here. We start out with a concrete saw to cut a certain diameter or a certain 1 foot by 1 foot, 2 foot by 2 foot. We'll make sure that the client is comfortable with that. We have a cold patch in the truck afterwards to make a nice repair, or repair it with some kind of quickcrete concrete to make sure that it's repaired back to the same state it was before we arrived. Then once we get down to the soils sub-base underneath the pavement, then we can expose the utility. So that's another sense there. And then you can see here where actually a trench can be cut, and you can see, I can see 6, 7, 8, 9, maybe even 10 utilities along that trench. That comes in really handy in the oil and pipeline business, where like an ExxonMobil might be in an easement with 7 or 8 other utilities, pipeline crude oil companies traveling across Texas or other states that are oil producing states into refineries and into plants. Next slide there. After all that geophysical information is done, after you've classified all the utilities to A, B, C, or D by a professional in charge, then you get the STU deliverable. And this is one example of what really ends up being good GIS data. My screen's fairly small. Hopefully you all can see this image well enough that you can see different colors, you can see different diameters. And what's really unique about this is that the GIS information, the line work that you see here, has attributes to it, not only of color, but of different dash line types that show that we found that line or that segment of the buried electric line to level B. We found this one to level D. So you can tell the client, we did our best pursuit, we did our best knowledge of where the utilities are. And right here is an intersection of Bell and Auburn Avenue. And it is showing the utilities then for the client. And for the engineer, really valuable pre-engineer at this point, where the engineer can make decisions of where that driveway is going to go, or maybe there's going to be a bridge. Maybe this is in that great intersection and it's time to make a bridge of Auburn Avenue over Bell Street. So now we need to know where we're going to put the bridge foundations and not have them impact utilities. So it becomes very powerful to know where those utilities are. So that is my presentation. Hopefully some good Q&A after. And thank you from me, Wes Kaisershot, CDH Utility. If you need to contact me, there's a resource tab where there's information to contact me. So thank you very much. With that, I want to introduce the next presentation to a leader at PelicanCorp named Abraham Alpuerto.
Good morning, folks. This is Abraham Alpuerto with PelicanCorp. And thanks, Wes and Mark, for this introduction. But basically, thank you for allowing us to come on and talk about SU, submarine utility engineering. And like, Mark was expressing, or Wes was expressing in regards to the engineering side, it's it's one of those processes when you take a look at what's really happening out there, the construction world and the lack of infrastructure information is now coming to a fold where really the reality of what's happening is going to be coming to the onset of mapping. So can we have the next slide? So in sub-utility investigations, we have basically the infrastructure of SUE is basically the details of sub-utility. One of the things that we talked about with 4M analytics is in regards to the basically a information that they put up on their website in regards to Jim Aspen in regards to this information about where SUE was planning phases of provides benefits such as avoiding unexpected utility conflicts, reduces delays, reduces risk of utility strikes and enhancement safety, and also saving money. Next slide. Another thing that in regards to SUE, CHW Inc. conveys that the well-being of SUE it basically says that it's a process, not a technology. So when we take a look at what SUE involves in regards to all this technology, it's really a accumulation of all this information that's going to be delivered to an engineer. And what we need to do is basically provide good quality data. And if we go to the next slide, that data becomes, part of this ASCE, which is pretty much a practice, and also in NOCA, providing this information so that way this particular product can be delivered to the engineers, so that way, it improves the project's outcome and safety. The technology investments have increased accuracy and efficiency through using different technologies like AI, machine learning, ground penetrating radar, electromagnetic locating, and foremost, digital mapping, because all that information needs to be acquired when you look at the information that's being pushed through a lot of this data. And we're going to go to the next slide showing kind of depicting what we're talking about. So in this, in the center, you're looking at basically a mapping system that which is GLANIS here, that's showing that the information is coming in as from a particular locate information that needs to be taken in, and then that information is now delivered to a data collection system. And that data collection actually can collect the attributes in regards to the X, Y, and Z, but not only that, in utilizing the GPS, like shown here with this particular GPS unit, particularly this bad elf one. And then also with the EM, it's also able to collect that information of those electromagnetic devices. Also, you could put in regards to the GPR. So when you've put this all together on a map from a data collection, you're able to, in the field, see this in real time. But at the same time, from an asset owner, you're able to actually see this while the technician is out in the field, or in regards to some of the engineering companies that we're dealing with, can actually see it at the same time. So if the information is crucial where they need that information right away, they could acquire that without really waiting for days to get that information. Information, when comes in, the automation of some of the post-processing can be done already with the software and then uploaded into whatever to the, or even a ticket management system, so that way there's no delay in regards to the actual transfer of information. But the crucial thing in regards to a lot of this is regards to the information, like Wes was expressing earlier on his slides, is all the data that's being collected is in real time. So from a level A, level B, which a lot of these locating companies are actually going out there and producing those type of qualities. It's not just painting it on the ground anymore. We're able to collect the information in real time, so that way, obviously, the engineering companies can actually get that information quicker, so that way it allows them to really get their job done quicker and faster, but also to make decisions in regards to making sure that they produce a better quality product. So that way, from the construction side, there's less avoidance in regards to trying to, do their work, but also that also helps in regards to getting the job done quicker and faster. So, and it also saves lives in the long term. Next slide. So here we have part of a deliverable in regards to what the actual client can see. And also in real time, they could click on to those points and see the metadata to see how well everything is being collected. So it's also rich in feature, so that way they can actually see, besides just points, now it's actual feature symbols that allow them to actually see and basically, see if it's a hydrant instead of a point, especially if they're looking for a certain hydrant or even telephone pole number that could be identified very quickly. The automation for mapping and reporting is also can be done very quickly. Just like what Marc was saying earlier with Esri, in regards to taking this information and spinning it out as a deliverable. Also in regards to the data collection side, the export's very important just because the information that needs to be transferred in to those certain companies like Esri, putting it into that database allows them to bring that in very seamlessly. Besides, engineering practices in regards to sometimes putting into civil 3D, you could either have as a DWG file or also a CSV file, which a lot of times a lot of the companies do require. Also, it's in real time, and the metadata, we could also filter out information that really they don't need or do need, and in regards to inspections and reports, that also can be placed in that data. Next slide. So in regards to the design practices or principles, a lot of times these systems are cloud-based. They are also, they can be fully offline in regards to acquiring that data. And then when they go back into the actual cloud or back into cellular coverage, they're able to upload that information. It's also automated seamlessly, and also in regards to some of the systems, if like, for example, if you're French speaking, and we could basically have a multi-language system that could go into different formats, because sometimes you have different languages like Spanish and Portuguese and all that. So the modern platforms in regards to using either iOS or Android system, also it's a generic kind of configuration that's scalable in regards to getting the product out and functioning very quickly, and basically it's easy to use. Next slide. So the QA/QC process in a lot of this data collection, as the technician is out in the field or in the engineering part of this whole practice, is really in regards to understanding the metadata that's being acquired. So it's not just when you look at the ASCE 3822 standard. It's not just the, horizontal and vertical, well, horizontal positioning, but it's also where I think the information in regards to the data information about that line, specifically like here, this is information coming from a EM locating instrument, has the frequency and current and gain, besides the depth, but also helps in regards to identifying if this particular line has been surveyed multiple times. You could see the attributes and really rectifying, hey, this particular line has been, degrading, so we need to investigate that for future use. So there's a lot of things that from an AI standpoint, these database systems can actually analyze in the future. It's just, collecting this data is very crucial in upcoming years in regards to building out territories or regions or even, municipalities that are out there trying to innovate or renovate their areas. So again, part of this whole thing is in regards to Sue, it's very important in regards to understanding how this is being done. So that way you could basically, from a construction aspect, reduce a lot of your time and effort by utilizing Sue in these phases. Next slide, please. So I don't know if you could see this clearly, but this is representing the metadata from this single point, and they were basically QCing this and noticed that certain attributes was going kind of haywire. So you're able to click on that point and visualize to see what's going on, especially if the depth in this case was going way deeper than it typically is. So the technical or the person that's actually analyzing this can actually say, okay, what's really going on? And you could see on the bottom right-hand corner there of the photo, you could actually see transformer that's there. So understanding that can kind of ease your mind in regards to, yes, I understand that transformers can distort that signal. So again, you could bypass that and just QC it in that way. But a lot of times, when they're getting this information, they don't really see and visualize what's really going on, because traditionally what happens is surveyors or whoever is locating will conglomerate all these photos, and the person that's actually going through it, which would be like Wes, and analyzing it, and basically they don't know exactly where in that line of 1,000 photos where it is, because it's not sequential most of the time, but it's also random. So this allows you from this particular point to really analyze where exactly it is, because it's feature driven. So this particular feature for that point will carry that photo, but also in regards to, seeing and visualizing other things with that, as things come up, you'll able to see, how this is being done. Next slide, please. So here, it's basically showing you the export for these particular points. And when you do that, again, it's crucial for understanding what points that they really need, so that way they could get their information quicker, and also to transfer that information and for the post-processing side to ease their mind, so that way it's more of a seamless operation. Next slide. So here is just an example when you zoom in, seeing the actual lines versus the actual locate area of where the client is going to, the excavator is going to dig up where the actual lines are. And here the product's able to, on the left there, show dimensions of how far the distance between where the excavator is going to dig versus where that utility is. So Next slide. So the advantage and methods in using data collection, one, you got the office and the field solution side of things, and allows you to seamlessly integrate that into today's information age of acquiring that data very quickly. Also, there's no post processing in the office that allows you to process that in real time. So that way, again, the information can be done very quickly. So that way, you can make decisions. Also, the GIS vendors that are out there, there's a lot of systems out there. And one of the things that, systems can be utilizing is actually, the GIS receivers that are centimeter grade accuracy, depending on also, what you're looking for accuracy. There's a lot of them. Also, the higher data quality in regards to making sure that that acquisition of that information is correct. We could actually filter out certain information or even discard that information in regards to making sure that only centimeter grade or 2 centimeters is your limit. That information is being acquired where it will throw out or prevent the locator to actually produce that as points. The other thing is optimizing the utility data collection system. Basically, in regards to that, you've got a better quality data in regards to the documents and making sure that it's acquired correctly. Next slide. So in the end, I'd like to express thank you for allowing us to come on and talk about Geolannis in regards to the Sioux. If you want further information, there are certain things in there. If you click on our name, that will be followed by other information that we've documented. Also, I want to introduce to you Chris Zuniga from Bad Elf, and thank you very much.
Hi, everybody. How's it going? Pardon me as I set up my screen share for a second here. Okay. Looks like I'm coming through all right. Thank you so much for coming to the webinar and hanging around until the end. There have been a lot of great topics discussed today. I'll do my best to build on this by providing insight into the data collection portion of subsurface utility engineering. My name is Christopher Zuniga, and I am part of the Geospatial Enablement team at Bad Elf. A large part of my job is coming alongside customers of our GNSS receivers and helping them develop their field operations. Naturally, I work very closely with a number of users that are in the Sioux industry. So today I will share some of the key insights from my work with our customers and partners. You'll also notice on the slide that we do have the best art director in town. Here, this graphic is just showing kind of what the digital process looks like for actually getting this Sioux data into your GIS, creating your digital twin. So that's pretty neat right there. But here's a quick overview of our agenda. We're going to start by providing insight into the importance of Sioux standards. Wes was thankfully able to touch on this a little bit more. Then we'll move into discussing each of the quality levels in Sioux and how they correspond to real workflows in the office and in the field. Next, I'm going to share with you a bit about Bad Elf and how our products actively support members in this industry. And lastly, I'll speak about what Bad Elf is doing to help folks catch up with new regulations and the latest mapping technologies. Before we get started, here is a quick poll. If you do have the time and aren't driving or anything, I do recommend going ahead and filling out some of those questions. This will give us some great data on who all is attending and what you're all interested in seeing. We will revisit this towards the end of the presentation and see what kind of insights we were able to glean. So the climate of subsurface utility industry is moving towards higher regulation. There are pros and cons to this, but the general consensus is that we want any infrastructure going in the ground to meet specific quality standards. Take, for example, the line strike we see in the picture. I am sure that this wasn't the way that this was supposed to go. And in fact, a recent article from the Times states that the official estimate is that every 7 seconds, somebody digs a hole in the UK. and 60,000 times a year, they end up wishing that they had dug that hole somewhere else. So if you do not know where your assets are, then they are no longer assets and they are now liabilities. It is exactly why the American Society of Civil Engineers is responsible for creating SU standards, specifically the Utility Engineering and Surveying Institute, where they have developed and maintained guidelines and standards related to SU practices. Again, you heard a bit about those practices from Wes, but I will be showing you specifically the role that high accuracy GNSS plays in getting the best results out of each quality level. At the end of the day, this is all to enhance public safety and risk management to help organizations protect themselves from mishaps like the one you see in this photo. So what are these standards exactly? And how does a high accuracy GNSS receiver play a role in this process? Well, again, Wes thankfully touched on each of these quality levels, but I'm going to go ahead and expand on each of them and provide some insight as to what each of these steps looks like, both in the office and in the field. Again, these are to ensure the safe and reliable management of our underground infrastructure. Starting with level D, we have records and research. Every data collection project begins with the research phase, and SU is no exception. Many times, this process begins by obtaining an as-built that shows the utilities when they were put in. These can be obtained from county clerks, engineering firms, power companies, and even the online AI cloud platform that Wes mentioned, 4M Analytics. However, the main point to remember about quality level D data is that it often arrives without any type of georeferencing. And even after georeferencing it, the data can still be outdated or inaccurate. For example, their point of beginning could have been a big tree that was there 30 years ago, but has since died and been removed. So here you see a septic plan, and there's not much to go off of. Obviously, this was built off of some type of survey for the subdivision, but just kind of pulling this up, we're going to have a bit of a time actually getting this into our drawing program or our GIS. Nonetheless, once you digitize this research data, you will have a starting place to go in and verify this data in the field. Let's discuss the next phases, locating and surface mapping. So the SU Association actually recommends skipping from quality level D to quality level B for step 2, highlighting just how critical accurate locating is. So during this phase, we'll focus on locating the underground utilities using those geophysical methods and verifying the information we gathered during the research phase. So this step is typically going to involve public services like 811 and includes using tools such as radio detectors and ground penetrating radar. These tools help pinpoint the exact X and Y locations of those underground assets, which are then marked, tagged, and recorded using a high accuracy GPS receiver. The importance of this step cannot be overstated. Accurate location data is essential for safe and effective excavation. If this information is incorrect, it can lead to significant problems, and this is where metadata and the ASCE standards play a crucial role. In the past, only surveyors could stamp maps with their approval, and today, thanks to ASCE standards, a professional engineer or PE, like Wes and many of you, can stamp this data even though they might not have been physically present at the job site. Instead, they're relying on the metadata and the attributes collected by the field crew and something like GeoLantis 360, which Abe was just speaking about. So by using modern technology and thorough documentation, the crew provides the necessary information for that engineer to make an informed decision about whether or not to stamp this data and to what quality level to assign it. This advancement is a game changer for engineering firms and municipalities alike. Quality level C involves surface mapping of the above ground utility assets. During this phase, we're going to document the features that are visible at the surface, such as manholes, valve covers, and other markers based on available records and field observations. This approach provides a general overview of utility locations, but relies heavily on surface indicators and historical data, which may not always be precise or up to date or exactly what they seem. Quality level C is useful for initial planning and understanding the general layout of the utilities, but it does not guarantee accuracy of the actual underground utility locations themselves. For more precise mapping, additional steps and higher quality levels like B and A are going to be necessary to verify and refine this surface data. So this ensures that any decisions made during the planning or excavation phases are based on the most accurate and reliable information. Finally, we have quality level A. This is going to build on the earlier data to provide precise verification. We're going to compare our findings in the field with our quality level D data. We will have already detected the XY positions of each underground utility, and we have a thorough understanding of how it connects to the surface. Assuming everything until now checked out and the metadata verifies that we took good data, it is time to see for ourselves with our own eyes what's really going on down there. This is called potholing, daylighting, and it is the step that confirms the exact locations, depths, circumference, all sorts of metadata that's going to refine and validate the data from the previous levels for the highest certainty, to use Wes's word. If you look closely at the picture on the right, you might see that this is not a picture at all. It's actually a 3D point cloud made up of 100 different pictures. So now that we have an understanding of the basics, let's move to how you can speed up SU using Bad Elf's integration and training. If you haven't heard about Bad Elf yet, here's some more info. We have always been innovators in the GPS industry and defined what it means to fully harness the power of your mobile device in tandem with a high accuracy GNSS receiver. We are technologically agnostic and work with a number of app providers like PelicanCorp and Pix4D to deliver an exceptional level of choice and control when it comes to designing your own workflow. We also stand by our customers in the field and live vicariously through their geospatial success. Our team isn't made up of hard-nosed salespeople and marketing gurus, but engineers and geographers that appreciate what our customers do to make the world a better place once they have the proper means to collect quality data. Instead of pigeonholing our users into proprietary software and predetermined workflows, we give those users a chance to pair our receivers with whatever GIS application they like the most. Again, we're agnostic. In many cases, this will be a GIS app like PelicanCorp's GeoLantis 360, which Abraham shared some insight on. As geospatial technology evolves, we have seen the divide between GIS and engineering get smaller and smaller, while the results and workflows are getting better and more efficient. By pairing this tablet to a Bad Elf Flex using Bluetooth, you're now able to replace that dusty and unwieldy data collector with a modern solution that allows for enhanced data collection beyond just the X and Y and a code. You're attaching metadata, you're attaching pictures, you're transporting your professional engineer who's in the office to the site. You're getting the best of both worlds here. That tablet is going to be great for annotation, typing notes, and snapping pictures, but it's not going to be enough by itself to actually capture a high accuracy position, which is where the GNSS comes into play. Another recent advancement in the world of mobile data collection is going to be that of pairing your high accuracy GPS receiver with a remote sensing application on your iOS device like Pix4D. Use this combo to make a comprehensive and highly accurate 3D scan of your assets while you have them exposed. You can then access the cloud platform later to make your annotations and measurements. So all this sounds a bit abstract, but let's follow it from field to finish. This is the scan of a stormwater basin that I collected in South Texas. The blue path is the path that I followed while scanning the ditch, and I was able to collect these points while connected to the Bad Elf Flex Extreme 4cm grade accuracy. It's attached right there on my phone. Go back to the previous slide. This is the setup. I have the Flex. It's receiving RTK corrections, and I have Pix4D catch open, and I'm going ahead and I'm walking all around the stormwater basin. You're able to follow me with this little blue line, and I was able to collect all of this. It's over 600 pictures. But whenever I got back to the office, here's what I was able to do. I was able to calculate all sorts of valuable information while working with a geo-referenced 3D model. That's right. Each one of these thousands of pixels has a northing and an easting accurate to less than 1/10 of a foot. All from just moving my camera around while connected to a GPS receiver. This brings us back to the picture we started with, a full scan of the exposed utilities. But you've heard enough about it from me. What do our users actually have to say? This is a testimonial by one of our power users in the subsurface industry, Magnify Utility Engineers. Jody and her team were great to work with, and we had a great success integrating with them and helping train their technicians, and they couldn't be happier, and were gracious enough to provide this testimonial and picture of them deploying the technology in the field. Again, everyone at Bad Elf is a geographer at heart, and we would love to help you get started collecting some high quality data for your organization. Again, their catchphrase is going to be magnify your results. The great folks over there. I think they're out of Pennsylvania. So don't be afraid to lean on the geospatial enablement team at Bad Elf. We're people. We have expertise supporting various industries and can help design a workflow and training structure that works for you and your team. And with that, we circle around to the results of the poll. So I'll go ahead and wait for those to pop up. Hopefully everyone had some time to go ahead and populate that with some answers. Awesome. Yeah. So it looks like about half of everyone on the call is currently implementing a GIS solution for their subsurface utility engineering. Very good. As far as people who are interested in implementing a GIS solution, we have about a split of 20% who are interested, 32% who are still on the fence, and the rest of everyone is either already implementing or are not interested in furthering their GIS applications with SUE. So third question, if you do have a GIS solution, are you interested in speaking to someone like me? About 12% said yes. I promise I don't bite. I have a lot of expertise in this field, and we can go ahead and we can guide you through this process. And finally, we have about 54% of the crew saying that they do need a GNSS receiver to collect field assets. So again, kind of went over everything, all the quality levels, the full process. That GPS receiver, getting high accuracy, pairing to a tablet is going to be crucial for each step of the process. So that kind of concludes what I wanted to talk about. If you have any questions, my info is on this slide, and I look forward to hearing from you. But that's enough out of me. I'm going to ask that the rest of the speakers come back on for us to do our Q&A. Go ahead and welcome everyone back.
All right. Great stuff. Christopher, Wes, and Abraham. We've spurred the interest of attendees. We've got a few questions here. I'm just going to start going through them. First of all, I do want to echo what you said, Christopher. You guys have got a great graphics design team. One of my favorite things, one of my favorite swag of all time is my Bad Elf luggage tag with the guy out on the tarmac waving in the plane. So yeah, you guys are great with your swag and design and graphics and great communication.
Thanks.
Yeah, first question here. Can subsurface utility engineering assign a quality level tag to specific utility to visualize on GIS software? Pretty big question there. I'll maybe just take a first tab at it, and I'm just about any feature in an Esri environment can be extended with various attributes and then use those attributes to do heat maps or hexagonal mapping or proximity analysis. So yes, from an Esri point of view, on a pretty broad question. I'm not sure if anyone else wants to talk about quality level tags and how you visualize that in GIS.
Yeah. Yep. So in regards to that question, yeah, GeoLanis can easily put that into our system and providing that documentation and how it's being processed as a level A, B, or C, depending on what the technician's verifying at that particular time and moment. So same with you, Mark. I totally agree with in regards to this information needs to be available to these guys like Wes because he's a PE and he needs to make those decisions, and allowing them to make those decisions with the proper information is very valuable. So
good deal. Agree. Anyone else want to chime in on that before we move to the next?
And I would say another way that would go would be me as a PE or someone else in charge of that deliverable would assign that quality level A, B, C, or D. And then it sounds like that could go back the other direction too, if I'm correct in hearing Mark and Abraham on that it could be then displayed for a client in GIS after that professional in charge has designated that quality level. So it sounds like the answer to that tag is yes, and it can go a couple different ways, but yes is definitely the answer.
All right. So yeah, I'm going to move on to a question here. I think this was pointed towards your way, Abe. How important or vital is it to acquire the metadata from an EML instrument?
So yeah, I mean, to me and a lot of my colleagues, and I'm sure a lot of the PEs will verify this in regards to capturing that metadata for the long term of understanding, their work. Also in regards to the long term of it, because some of these projects are not just a short-term project. It may be a long-term project for example, municipalities where they build upon, information as years go by. They have that information, just like land surveyors and also engineers. They have records of that information that compounds. And with the proper information, that spends less time trying to dig up a lot of that information when they could actually see it in on a digital format, because again, part of that is in regards to the old fashioned way was putting on drafting it on a paper and then archiving it, as a blueprint, and finding those blueprints sometimes can be difficult in regards to when it was done. And yeah, I mean, we have computers now, but having it digitized in real time with that information, they can go back to it very simply. So
I mean, you said a word there that it took me a little bit of time at Esri to realize certainly the location elements of GIS are critical. I mean, it's the connector. But there's also a time element, a temporal element, and being able to use that to understand context, existing conditions, informing designs. I know that's what 4M does in particular. I've met with them a couple of times as far as collecting imagery. And time element of that imagery is helps you know where things are. So it's not something that immediately comes to mind when you think of GIS. You're thinking of maps, you're thinking of location, you're thinking of field data collection, you're thinking of imagery, but all of that being time stamped in some way or another just creates a whole other perspective, if you will.
Yes, absolutely.
Let's see, another question. This one, again, big question. How do you track and visualize 3D underground infrastructure?
I can definitely help with that a little bit. So,
Chris.
there's a couple ways that you could have actually gotten this information, right? So is it just an X, Y, and Z, that was taken from a GPS, or is it the actual 3D model that you did with something like Pix4D? So if it is Pix4D, they have a pretty robust cloud platform. I was going to pull it up, but it might have been a bit much. But basically, that picture that I showed with the actual 3D scan of the exposed utilities, you can go ahead and you can navigate in there like a 360 camera. You can go ahead and see all of that. And that's also where you're going to be able to take your measurements, measure your volume, measure slope, and then share your annotations in your quality report after. So that's a great question. If it was just through some type of GIS application like Geolantis, they have a cloud platform as well. You can go ahead and you can look at the X, Y, and Z's of all of your points and all of your assets. So there's a number of different ways that you can actually track and visualize those underground infrastructures in 3 dimensions.
Yeah.
You bring up kind of both sides, the coin, kind of just the pure, GIS information, which might appear 2D, but through color coding or through other mechanisms, you have tagged it with a 3D element, and then you put that to use. There's the BIM content, the 3D model content that is essentially often as planned or as designed and hopefully as constructed. And then, there's a whole gamut of technologies evolving for using photos of what gets installed, and those photos being geotagged. And in some cases, I know we have a group at Esri called the AEC Innovation Lab. I just met with the director of that the other day, and he was telling me about a work that they're doing. So it's actually video around an open infrastructure site. And then we're working towards technology to turn that into geolocated 3D NERFs, NERFS. That's kind of bleeding edge stuff. So yeah, the area of 3D infrastructure and its impact and intersection with GIS is a great one. Plenty of opportunities today to do it, and more in the future. Abraham, anything else to add there?
No, like Chris was mentioning, our system, and like yourself, the 3D information is, to me, that's where it's going to go. In visualizing stuff in three-dimensional. I have stuff that in the future we're working on in regards to, really capturing not only in 3D, but also visualizing in the field in 3D, because that's how you take a look at BIM, building information modeling. It's already there. The systems, from glasses to Oculus to all these type of 3-dimensional systems that are already out there, people are using it. It's just, that's been out there for a while, long while, over 10 years. Now, it's slowly integrating into our sector of the world in damage prevention. So yeah, I could see that coming down the pipe very shortly, just because innovators like ourselves are pushing the envelope, so that way, the biggest thing for us is, for safety, we're in the prevention side of things. So making sure, the product is not only quality, but it's also making sure that, it's safe for individuals to use. So that way, everybody could go home safely at home at night. So.
If I can add, Mark, from a SUE standpoint, it's becoming very evident that 3D modeling is just going to be the course of the way things go. Many DOTs are requiring their SUE information to be delivered in a 3D model. The first question is, you would just want a 3D piece of information like a test hole or a daylighted test hole at that spot, but more than likely they want a 3D model of the whole span of the utility network, rendered, if you will. And that's because terrain models are becoming 3D. The bridge and the bridge vents are 3D. And so to have utilities in just the 2D sheet map is not enough anymore, because they're looking for that clash detection now. They're trying to say, well, look at this pipe that's going through your proposed bridge vent. We're going to have to do something about that. Yeah. And so it's becoming a standard, and a company like us that can gather the data, that can go to companies that are being talked about here, like PelicanCorp, Bad Elf, to help that whole 3D rendering go. So it's really a team effort there, and an opportunity for a lot of companies to come together and assist each other.
Yeah, I've seen some brilliant technology from a couple of Esri partners that are taking multiple sensors, scanning underground conditions, and then using AI to combine the various signals that come back and generating 3D models of existing conditions at a level of of quality and accuracy and trustworthiness that just a few years ago we would not have expected. And it's opening the door to the expectation that that's just the way information can get delivered. A 2D map that's color coded without trust of accuracy or depth is perhaps yesterday's expectation. Great. Let's see. Another question, interesting one that I might have asked myself. Why do I need GPS if I only needed a mapping tool to create a sketch? Is GPS overkill, or is just GPS the standard of care now?
Well, that's a very good question, because there are certain areas, like for example, Canada is one of them. In regards to they are mandated to provide a sketch. So any of the locating companies that are out there, they have to provide a sketch within a couple of days in regards to what they've done and finding. So it's crucial, I think, in regards to making sure, not only from providing kind of an as-built, but to me, because our product is agnostic, but also in regards to utilizing like a Bad Elf GNSS receiver alongside with our product, they could capture in real time as they're doing the work. So when you look at the time savings, where a lot of these companies can really instead of sketching it and taking the time in their truck to create that sketch, because when you're creating a sketch, you're hypothetically just drawing a line, whereas you're actually providing real-time information to a PE like Wes, in regards to making a better decision in regards to not only the quality level, but also what's out there, what's in real time, what are you finding, so that way that information is very viable. And it's also in a lot of cases, what we talk about to these clients that are looking for a sketching tool is, why are you sketching? Why don't we just digitize it? Because at the end of the day, you got to digitize it anyways. So why put a pencil on paper, well, you could do that while, you're walking out there and mapping it. So.
And those are great points, Wes. I would say that GNSS data collection in this type of field is quickly becoming the industry standard. In the past, it was only surveyors that had access to the knowledge, the tools, the technology, the integrations required to actually precisely map things. That is not the case anymore. One of the ways that we've tried to innovate this industry as much as possible is lowering the barrier to entry to collecting quality geospatial data. So again, it's becoming the industry standard because it's just more efficient. You're able to ensure your quality. And at the end of the day, you are wanting a digital deliverable, and you're not even able to capture any 3D information if you are just doing a sketch.
All right, thanks for the feedback that my audio wasn't working well. I think I've turned it up, and hopefully you can hear me a little bit better. That'll teach me to mess with my hardware just before a webinar. Question came in, sort of what we were talking about just a couple of minutes ago, I think, on the 3D. How do you locate the unlocatable pipes, especially aged infrastructure, to assign a quality level? This was directed at Wes, but I think others could answer. And how often do you run into unlocatables during SU investigations? So how do you find them, and how often does that happen, I guess, is the question.
Yeah, great question. So unlocatable could mean unlocatable from a pipe and cable locator where it needs to pick up an electric field around that pipe. So there you want a metallic pipe, lead, copper, metallic pipe of some kind. When it's not found that way, GPR can find unlocatable pipes. So if you're thinking about like a PVC plastic line that's not going to show up on a pipe and cable locator, the ground penetrating radar is picking it up from a different way than pipe and cable. It's not looking for electric field, it's looking for a shape of a disturbance underground. So it's sending waves down into the soil, and it's finding that unlocatable utility that doesn't have a tracing wire, or again isn't made of metallic material. That's another method. If you can go into something that's non-pressurized, like a gravity flow sewer or a storm drain system, and drop down a manhole, and you can kind of snake through a sonde and put 1,000 feet or so of spool line with a sonde, now you've created and induced a locating instrument underground that you can capture at the surface. So there are a number of ways there. And then when push comes to shove, you might use AI. You might try to get as close as you can. And then if you have enough certainty, then you might actually then start to excavate down in hopes that you know where that utility is. Sometimes it's 2 or 3 test holes before you find it. But if it's that important, then you'll be doing that for the client until you just really can't anymore. So how often do we discover that? Quite a bit. I would say half the utilities on a project are easily locatable. The other half take a little bit more effort. So you use different tools in the toolbox until you run out of options completely. And you can always test hole down and try to locate it physically with a level A type of investigation. Good question.
Anyone else want to touch on that before we move on? I have time for one.
Yeah, a couple of things in regards to that. I totally concur with Wes. We deal with a lot of that situation also, because questions in regards to how does a locator create that information in regards to logging that, right? Because a lot of times, they don't really position it correctly. So in our part of our feature-rich information, we're able to log that in. So that way, again, utilizing, GPS, which Bad Elf provides. And, as long as the locator is using a sonde to acquire that data with an EM or actually the GPR, we'll be able to produce that in our system and then upload it to a shapefile, giving it to Esri. So yeah, it's a full circle. I look at it in regards to acquiring that data, but it's a lot of times it's the locator that's in the field, understanding what they're going against, but also, in my experience in regards to locating, one of the things that I try to do is actually talk to the engineering companies like Wes and say, hey, what do you have already that's already part of the system? and let's put it on my database so that way we could see it as a background information to help verify position, but also in regards to, yeah, that's not in the right position, or yeah, we found more stuff branching off of that particular line. So, it helps in regards to speeding up a process, so that way the locator is not guessing, but also in regards to improving the quality, because again, that line might not be identified as that particular level at that particular moment. It might be just a line that was driven by a level C or level D information. So again, utilizing the technology and who's out there in regards to information, that for a full circle is really getting the best data information that a client will, like Wes's company will receive once, the proper documentation has been transferred correctly.
Great.
So.
Okay. We got about 2 minutes here, I think, left, and I'll throw out a question that probably could be discussed for half an hour. Can your
Always.
mapping tool overlay other georeference line work? I mean, certainly in the case of Esri, we bring in, I saw a list the other day, some 300 different file formats, which range from interoperability CAD and BIM files like IFC, proprietary formats like Revit, DWG, open formats, DXF, FBX, OBJs, certainly as shape files. So yeah, and we even can take a spreadsheet and interpret it and turn it into line work, georeference. So tons of ways. I'll maybe hand it over to some of the other folks here just to real quickly probably just answer yes or no with
Yeah.
one.
Yeah. For us, yeah, absolutely. So
Part and parcel of the process, right? It's what you do.
Yep.
Okay.
Yep. So.
All right. Well, I don't know if Christopher or Wes, anything on that topic.
I would just say that having reference data that can add to your situational awareness in the field is very important. And if you're utilizing just your phone GPS, oftentimes that's not going to be accurate to 15 feet. So this plays a very big role in field operations. So having that ability is crucial.
All right.
Yeah, I agree on that. Nothing else to add. It's good answers, Abraham and Chris.
Well, with that, I think we can turn it back over. We are at 90 minutes now, I think, and appreciate the opportunity to talk about an important topic, and great panelists joining and sharing expertise, and great questions from the mostly US-based attendees.
Thank you, everybody, for joining.
Yeah, thank you. 100
Thank you,
people
guys.
hung on there towards the end. Thank you all.
Take care, everyone.
Yeah.